Okay, now let's look at this question. The question says there are two forces acting on a block. One force is having a magnitude 10 Newton and acting along each direction. The second force has magnitude of 20 root 2 newtons and acting along northeast direction. Now the question says that we have to find the magnitude and direction of the resultant force acting on the block. So let's first say we got force vector A, which is 10 newtons towards east, and we got force vector B, which is 20 root 2 newtons towards north east. So let's draw the vectors. Let's say this is the vector A, is pointing towards east direction. This is our vector A. Then we get this is the vector B. This is our vector B. Then the angle between A vector and B vector will be 45 degrees. Now let's draw the parallelogram. So this is our parallelogram. Then the diagonal of the parallelogram will be our required resultant vector. So we have to find the magnitude of this diagonal. But the question also says that we have to find the direction of the vector. So to find the direction, what we need is, we need to know this angle over here. Let's call this angle alpha. So first, let's say this vector is C vector. Then C vector is equal to A vector plus B vector. Now let's first find the magnitude. So magnitude of C vector will be C equal to root of A square plus B square plus 2AB cos theta. Putting the values of A and B and theta. So A is 10 newtons and B is 20 root 2 newtons. So 10 square plus 20 root 2 whole square plus 2 times 10 times 20 root 2. And cos theta, the angle between A vector and B vector is 45 degrees. So we get cos 45 degree, which will be 1 by root 2. We have to find this value. So we get under root of 100 plus 800 plus this root 2 will get cancelled out. So what we are left with is 400. So this will be equal to square root of 1300. This is value C. Or we could say that this is equal to 10 root 13. This is the magnitude of C vector. So our first task is over. We have found the magnitude of vector C. Now we want to find the direction of the vector. For that, we want to know the value of angle alpha. Now how to find the alpha angle? Let's draw the figure again. This is A vector. This is B vector. This is A vector. This is B vector. Then, now let's draw the parallelogram. So this will be our parallelogram. Okay. So this diagonal will be the resultant vector C, and we want to find this angle alpha. Now let's make some geometric constructions. Let's elongate the side with vector A, and from this point we drop a perpendicular to this previous side. So we get this angle to be equal to 90 degrees. Now this side is B, then and this angle is 45 degree. So for this triangle over here, the perpendicular will be B sine 45 degree and the base of the triangle will be B cos 45 degrees. This will be equal to B by root 2, that is 20 root 2 by root 2. So we get this to be equal to 20. Similarly, b cos 45 degree will also be equal to 20. Now let's reconstruct this triangle. So this is the total base, this is the height, and this is the vector c. So this angle is alpha, this side is 20, this angle is 90 degree. The base of the triangle will be a plus b cos 45 degree. So a is 10 plus b cos 45 degree is 20. So then we can find the angle alpha. We can say that tan alpha is equal to 20 by 30, or tan alpha is equal to 2 by 3. So this way we have found the angle alpha.